Welcome to the Thomistic Institute podcast. Our mission is to promote the Catholic intellectual tradition in the university, the church, and the wider public square. The lectures on this podcast are organized by university students at Thomistic Institute chapters around the world. To learn more and to attend these events, visit us at thomisticinstitute.org.
As March announced, the title of the talk is Do Trees Have Souls? I think the subtitle is Aquinas on Natures. An alternative subtitle would be something like An Introduction to Aristotelian Biology. In Richard Powers' 2018 novel, The Overstory, one of the characters is a botanist who studies forestry. The seeds of the fictional Dr. Westerford's career are planted in her childhood by her father, an agriculture extension agent, who takes her on trips to visit farms. He especially teaches her to observe trees, their different types, their behavior, and their role in ecological systems. At one point, he says to her, "We know so little about how trees grow. Almost nothing about how they bloom and branch and shed and heal themselves. We've learned a little about a few of them in isolation, but nothing is less isolated or more social than a tree." What trees are and how they do what they do are among the most natural questions for human beings to ask. They are scientific questions to draw on observation, as well as philosophical questions. And they are philosophical in the obvious academic sense of inquiring into the nature of knowledge and reality and into the categories we will use to make sense of the world. But they are philosophical also in the more general sense that for practical, emotional, and even existential reasons, understanding trees seems to get at the heart of understanding who we are and our place in the universe. Flowers are beautiful, many shrubs are useful, but the ruler of the plant kingdom, the most noble of all, are the trees. For long before Powers' novel, literature has been full of trees. Obviously, they can set a mood and give a feel for location, as the lush spruce and maple trees in Wallace Stegner's Crossing to Safety, or the spare box elders and cottonwoods of Willa Cather's My Antonia. A particular tree can be bound up with a character's identity and life story, like the olive tree that Odysseus used to fashion his marriage bed, or the oak tree that becomes a symbol of generosity for Jem and Scout in To Kill a Mockingbird. More than that, trees can seem to have a personality themselves. We anthropomorphize them. We even divinize them. They can be literal characters like generous friends, as in The Giving Tree by Shel Silverstein, or like wise counselors, as the Ents in J.R.R. Tolkien's Lord of the Rings, or even sacred spiritual forces, like the Tree of Souls in James Cameron's Avatar. Across all cultures, trees play a key role in legend, religion, and myth. Christianity is no exception. Even a post-religious culture finds meaning in trees. A year ago, almost exactly, on September 28th, the world mourned the felling of a famous tree, a lone, picaresque 200-year-old sycamore, which stood 50 feet high in a field in a gap between two hills along Hadrian's Wall in northeastern England. The senseless, intentional sawing down of the tree was an outrage. It felt like a murder. And insofar as the tree was an unofficial national symbol, even an act of treason. Annie Dillard, in The Pilgrim at Tinker Creek, says, "The present of our life looks different under trees. Trees have dominion," she says. Our appreciation of trees also seems central to what makes us human, and those who fail to appreciate them seems to have lost some essential element of humanity. In C.S. Lewis's That Hideous Strength, sale of a college campus's woods is the first sign of a threat from soulless technocrats who dream of replacing natural trees, messy, dirty organisms, with structures of light metal alloy, clean and easy to handle. "At present I allow we must have forests for the atmosphere," says Filostrato, an Italian scientist. "Presently we find a chemical substitute, and then why any natural trees? I foresee nothing but the artificial tree all over the earth. In fact, we clean the planet." It's Italian, right? Living things are messy, full of imperfections and unruly. Lifeless things, like metal alloys, are pure and easy to control because they are sterile. Minerals are clean dirt, but the real filth is what comes from organisms. Sweat, spittles, excretions is not your whole idea of purity. One huge example. The impure and the organic are interchangeable conceptions. None of what I have said may seem to address the question of whether trees have souls, but I hope to have helped to motivate that question. Maybe some would ask if trees have souls because they sense that trees are a personal presence, more a thou than an it. Or maybe because we value them and think they have a dignity and worth, a distinctive life and nobility, deserving recognition, or even ethical or legal status. Aquinas actually considers whether killing plants is a sin at the beginning of the Summa's section on murder. Just as it may spring from different motivations, the question whether trees have souls can also be given different interpretations. Is it a scientific question to be answered by rational inquiry, or a religious question to be answered by spiritual authority? What is meant by soul? I will get to these issues in due course, but first I want to consider, what is it to be a tree? Tree is an abstract word. In Aristotelian logical terms, tree may be a genus with a common definition covering many varieties. In terms of modern biology, tree is not a genus, nor a family, order, class, or even phylum. It's a non-monophyletic taxonomic group under the kingdom of plant, which is a fancy way of saying that tree is such a high-level concept, stripped of particulars, that not all the diverse actual instances of tree-type organisms that come under the concept share a common plant ancestor. Being aware of this, it helps to have in mind particular kinds of trees, and even a particular tree. I hope you can envision particular trees you can recognize from personal experience, and that you are familiar with their distinctive features and characteristic behavior. Before this talk, March took me on a walk around campus, and there are some awesome trees on this campus. Maybe you have a favorite one that you've stopped and looked at for a while. For while tree is a very abstract word, what is true of any individual tree is that it has distinctive features and characteristic behavior that set it apart as belonging to a determinate species of tree. Features that even help it to grow and flourish, or not, as that particular individual member of that species. Growing up in Vermont, I came to appreciate the sugar maple. A particularly large one grew up in our backyard, and many more in the woods surrounding our house, and that kind of tree is common and important to the state. The sugar maple, scientific name Acer saccharum, has a distinctive, sharply pronounced tripartite leaf, a shape open and bold enough to be a national symbol for Canada. Sugar maples grow slowly, reaching 150 feet tall, and they can live for 200 to 300 years. Their wood is hard, dense, with beautiful grain, so it is highly favored by furniture makers. Like some other maples, their leaves turn bright orange and red in the fall, making Vermont famous for painterly landscapes during the tourist-friendly foliage season. And of course, sugar maples are famous for their sap, which runs most freely in early spring when the temperature fluctuates daily between above and below freezing. From a tapped tree, it will flow, light and watery, and with just enough sugar that it can be boiled down at a ratio of 40:1 to make delicious maple syrup. If you have ever tried it, you know that alternative versions of pancake syrup are no substitute. But for the same reason the precious sap is so distinctive, it can also never be fully mass-produced, never industrialized, in the way that, say, chicken egg production has been industrialized. As the essayist Noel Perrin explains, that is because of the nature of maple trees themselves. They are not a bit portable, neither do they grow fast. 40 years is a good average from the time you plant a sugar maple until the time you can start tapping it. You have to take them where you find them. Now, living in Maryland, behind my house there is a weeping willow, scientific name Salix babylonica. In physical appearance, there is no mistaking it for a proud and sturdy maple. The weeping willow's leaves are small and elongated, its branches drooping. They only reach about 80 feet tall. My familiar specimen is not even half that. And they typically don't live much more than about 50 years. For only its brooding posture and short life, the weeping willow seems aptly named, but other features also suggest fragility and melancholy. The weeping willow prefers soft, moist soil, such as along a riverbank, and is at home in colder and temperate climates. The wood of the weeping willow is light and soft, and the bark is acidic, bitter, historically put to medicinal use. Desdemona, in Shakespeare's Othello, famously sings of this mourning tree. The fresh streams ran by her and murmured her moans. Her salt tears fell from her and softened the stones. If the sturdy sugar maple and the mild weeping willow sound very different from each other, they are both very different from a famous tree of the American West Coast, the giant sequoia, scientific name Sequoiadendron giganticum. I have seen them in California and Oregon. Giant sequoias can reach over 250 feet tall and can live at least an order of magnitude longer than the maple, more than 2,000 years, more than 3,000 years. The giant sequoia needs a humid climate, tolerating a dry summer accompanied by a snowy winter, and it thrives in a deep alluvial soil. The mature wood of the giant sequoia is fibrous and brittle, and its bark is actually fire resistant. The tree even seems to benefit from fire, not only to suppress competing species, but to strengthen the tree and open up its seed cones. Annie Dillard, again, described the giant sequoia as, practically speaking, immortal, vulnerable only to another ice age. I have just described 3 specific species of tree, and perhaps by now you are thinking, this doesn't sound much like a philosophy lecture. What does any of this have to do with whether trees have souls? Yet by starting with observation of particulars, I am only trying to follow the method of Aristotle himself, who said in one of his treatises on nature, on generation and corruption, lack of experience diminishes our power of taking a comprehensive view of the admitted facts. Hence, those who dwell in intimate association with nature and its phenomena grow more and more able to formulate, as the foundations of their theories, principles such as to admit of a wide and coherent development. He continues, while those whom devotion to abstract discussions has rendered unobservant of the facts are too ready to dogmatize on the basis of a few observations. The distinction Aristotle is making here between allowing our theories to develop on the basis of actual observation of particulars, rather than developing abstract theories and then dogmatically imposing them on experience, is often more associated with a great critic of Aristotle, the prophet of scientific revolution, Francis Bacon. Bacon may have been justly attacking some self-described dogmatic scholastic Aristotelians, but as we can see even from this short passage, Aristotle himself agreed with Bacon about grounding scientific theory in empirical observation. Indeed, much of Aristotle's brilliance as a philosopher was due to the fact that he was a keen observer of the world of living things, poking, dissecting, recording, classifying, testing, especially, but not only, sea creatures. Before Aristotle was the philosopher, he was a relentlessly empirical biologist. In the words of Darcy Wentworth Thompson, a very great naturalist and a student of life itself. For Aristotle, said Thompson, biology was no mere byplay of his learned leisure, but was a large intrinsic part of the vast equipment of his mind. Aristotle even criticizes Plato for being too purely theoretical or logical in analyzing nature, and he sides more with an atomist, Democritus, at least for a more appropriate naturalist approach, basing his atomistic theories on observation. Here is Aristotle again. The rival treatments of the subject now before us, generation and corruption, coming to be and passing away, will serve to illustrate how great is the difference between a natural, which is to say observational and questioning, and a logical, that is deductive and abstract, method of inquiry. As St. Thomas explains, in commenting on this passage, Aristotle shows why Plato failed more than Democritus in this matter. And he says that the reason why Plato could not see confessed things, that is, things plain to all, was lack of experience. For being intent on speculation, he did not turn his attention to sensible things, which are the basis of experience. Consequently, this is still Aquinas, those philosophers who paid more attention to sensible and natural things were better able to discover principles to which they could adapt many facts of sense observation. But the Platonists, who were untaught with respect to existence, to natural and sensible things, and considered solely the few sensible things that came their way, from many discourses or arguments, that is, from many things they considered by reason or on the universal plane, they facilely enunciate, that is, they offer a judgment on sensible things without a diligent examination. Just a little bit more, Aquinas continues, the matter at hand affords us an opportunity to consider the difference between seeking the truth physically, that is, naturally by examining natural things, as Democritus did, and seeking it logically, that is, by reason attending to common reasons, as the Platonists did. So as you see, I am trying to follow the method recommended by Aristotle and Aquinas in reviewing specific common evident observations about three types of tree, which I hope are somewhat familiar to you, in order that we may start philosophizing on the basis of that observation, grounded in what we know from experience. The goal is to avoid a dogmatic, deductive, or abstractly theoretical procedure, such as Aristotle associated with the alleged science of the Platonists. With our pre-philosophical, pre-scientific observation of various kinds of tree in mind, what we can ask next is, what would Aristotle think of modern biology? Are modern biologists more like Democritus, who, although he had a too simplistic atomistic metaphysics, was at least driven by observation to develop his theories? Or are they more like Platonists, too attached to and somewhat blinded by abstract theories, and basing their alleged conclusions about nature on theoretical commitments conceived prior to and independent of observation? That was a long first section of the talk. So now part 2 is called Explaining Trees, Modern Biology. Modern biology has illuminated much about the mechanisms of organic life. One of the most exciting things to explain to children, for instance, is that a tree's great mass doesn't come from soil or water, but from the air. Some of you recognize what I'm talking about? If not, this might blow your mind. Tree mass is primarily carbon, and the carbon that makes up the body of the tree was once part of a carbon dioxide molecule in the atmosphere. To its great credit, modern molecular biology and biochemistry can explain the process in fantastic detail. Photosynthesis produces oxygen and ATP from light and water, and the Calvin cycle uses these to produce sugar from the carbon in carbon dioxide. Some of that sugar is used by trees to drive its cellular respiration, a key activity of any living organism, and what is left over is used to build the parts of the tree: trunk, roots, bark, branches, leaves, flowers, seeds, fruits, all the parts that depend on that cellular respiration and put it to use for the tree. Indeed, thanks to modern science, we can think of a tree as a kind of machine for drawing carbon out of the air and fixing it into something solid. The metaphor is so powerful that many have looked for ways to improve on this work of trees. Today, you can invest in one of many ventures in industrial carbon capture, developing machines designed to take carbon out of the atmosphere and sink it. These are essentially attempts to make artificial trees, just as C.S. Lewis predicted. But as soon as we are tempted to think of trees this way, as carbon filtering mechanisms, we should notice that the tree is more than a machine, and it doesn't only draw carbon from the atmosphere. The tree doesn't merely sink the carbon, it fixes it, that is, arranges it in a distinctive mode. For each tree has a distinct pattern, a blueprint or architecture for storing the starch and the sugars. The way a maple tree organizes and assembles carbon is different from the way a willow or sequoia organizes and assembles carbon. And this is precisely why we can tell the difference between these kinds of trees, because their trunks, bark, branches, leaves, and seeds are different. So although from one perspective we can think of the tree as a set of abstract chemical processes, it cannot be reduced to processes. The tree is more than a set of chemical reactions that can be captured in a formula. It is an organism that makes use of chemical reactions while also directing them, including using them to build the conditions under which they can continue to be useful. The tree grows, it increases itself as the kind of thing that it is. It protects itself and even heals. You can carve your initials in the smooth bark, and over time, a scar will form. It works to propagate its kind through reproduction. And it has such an abundance of activity, it is even generous, seemingly profligate in its work, providing shelter and shade and food for other species. The mechanistic temptation assumes that because a whole depends on parts, that the whole is nothing but the parts. The tendency in modern science is toward a theory of nothing but. The tree is nothing but its tissues, which are nothing but cells, which are nothing but proteins, which are nothing but molecules, which are nothing but protons and electrons and neutrons. And soon this analysis of nothing but leaves us with no tree, but only an insubstantial cloud, mostly empty space between countless invisible particles. The problem with this is that organisms are real and have causal agency, including over their own parts. Unlike machines, the parts of an organism need to be explained in terms of the whole. The whole actually helps to create the parts and maintain them, drawing on their chemical matter and assembling them into cells and tissues by an active organic power. This is what makes a living organism such a drastically different mode of being from something lifeless. It has its own intrinsic principle of order and unity and activity. It is not just a whole that depends on parts. It is a whole that orders its parts, a whole whose parts depend on wholeness. You don't get maple sap or maple wood without a maple tree, and you can't assemble a living maple tree out of dead maple parts. If your analysis of a tree or of any organism treats the organism as something to explain away in terms of parts, rather than as something itself that has causal and explanatory power, then you are not doing justice to the organism. Empirical observation tells us that a tree has parts, and that those parts have processes that enable the tree to do its characteristic work. But that does not mean that the tree and its characteristic work just is those parts and processes. To assert the latter is to move from beyond the realm of empirical fact to the realm of an abstract metaphysical theory. Modern biology is very good at paying attention to parts, analyzing organisms in terms of organs, organs in terms of tissues, tissues in terms of cells, cells in terms of proteins and chemical reactions. And all of these accounts are true and useful as a matter of empirical observation. But modern biology is less good at recalling the original primary reality of the whole, which is primary precisely because it has a work or activity of its own. This is partly a matter of language. It is not clear that modern science has a ready vocabulary for talking about modes of being that are primary, except in terms of what is smaller and constitutive of something else. Aristotle had vocabulary for the distinction between a primary type of thing and that type of thing which depends on a primary type of thing. He called the former substantial and the latter accidental modes of being. Accidental here does not mean a fluke or a mistake, but a relation of dependence. For an accident to be is for it to be in relation to something else, which is to say, it is for something more primary to be in some way or other. But for a substance to be is a primary way of being and does not depend on something else being in some way. To be a substance is to have an intrinsic wholeness, unity, and specific nature with its own distinctive power to act and be acted on, its own distinctive work. Aristotle also had a vocabulary for that which makes a substance to be a substance, that which endows it with its wholeness, unity, and specific nature. One of his words for this was energeia, which comes from the Greek word for work or function, ergon, and is a direct ancestor of the English word energy. The energeia of something is what enacts it as the kind of thing it is. It energizes it as this thing and not some other thing, and endows it with its specific powers as that kind of thing. Another word Aristotle used for this principle of substantial being, a term he apparently coined himself, was entelecheia. This term includes the Greek word for purpose or goal, telos. The entelecheia is that which fulfills a thing, brings it to the state of being that it is meant to be, and maintains it as that very thing. As one Aristotle translator, Joseph Sachs, has suggested, if energeia means being at work, entelecheia means being at work staying itself. In English translations of Aristotle, both of these words are typically simply translated as actuality. And we can say this, the energy, the energeia, or the entelecheia is that which actualizes a substance to be that substance, that one whole with its specific characteristics, powers, and proper work. This foray into Aristotelian vocabulary has gotten seemingly technical and abstract, so it will help to think, again, in terms of particulars. Recall our observation of the sugar maple and weeping willow and giant sequoia. From the standpoint of molecular biology, each of them is a complex machine for fixing carbon out of the air. But to know the sugar maple as a sugar maple, distinct from a weeping willow, one has to know how its leaves grow in this shape rather than that, how its bark is furrowed in this manner rather than that, how its seeds take this form rather than that, how its wood grows with these qualities rather than those, how its sap flows with these characteristics and not others. What enables the maple tree to do its maple tree work, to activate the behavior of a maple tree, to perform maple tree powers rather than willow or sequoia powers or no powers at all? The explanations of chemistry in terms of molecular bonds only take us so far. Something is organizing and ordering those parts as parts of a whole. Something is making there to be this maple-kinded whole, which is in a sense prior to the parts and on which those parts depend. Cells and molecules and electrons and protons and neutrons are parts of the maple, but that doesn't mean that the maple is nothing but these parts, because those parts without the tree are not parts of a tree. The tree is giving those parts their status as parts, much more than the parts are giving the tree its status as a tree. What gives the maple tree its status as a maple tree, a distinctive kind of organism? That something is what Aristotle would call its actuality, its distinctive energeia or entelecheia. In the terms of modern science, this is what keeps a tree, apparently defying the law of entropy, the internal, unifying, vivifying principle of organizing and exchanging energy and matter. Another word Aristotle has for this specific tree-making principle and power is substantial form. In general, a form is the intelligible structure or organizing architecture that gives something its character as what it is. The substantial form is what gives a substance its mode of being this kind of substance. It is that which makes it possible for us to apprehend with our minds, even before we can define, the difference between what it is to be a maple tree and what it is to be a willow. We see what they are and apprehend that they are different by virtue of their different eidos, idea, or form. Finally, a word that Aristotle has for the substantial form or actuality of a living thing is soul. In Greek, psyche. In Latin, anima. The psyche or soul is what gives a thing life. The anima is what animates. And in the case of organisms, this always means the specific kind of embodied life it has. My old maple tree in Vermont and the willow behind my house in Maryland are both still alive, and what gives them their life is their soul, which also gives them the kind of life they have, maple tree life for the tree in Vermont, willow life for the tree in Maryland. My strategy for introducing Aristotelian concepts here has been less to treat them as part of a theory than to show that they are a vocabulary that answers a need in any theory of what makes organisms to be organisms, any theory that would avoid analyzing organisms away with reductionist mechanistic accounts. Modern biology hasn't so much discovered, much less proven, that Aristotle was wrong, as it has ignored the category of organism. There are two general pressures that cooperate to obscure the role of the organism in modern biological science. One, which we have already discussed, is the tendency to explain wholes in terms of parts. We could call this the Democritean pressure, like the Greek atomists seeking to reduce larger things to smaller and assuming that the smallest particles are the most real. Aristotle could respect this because it was genuinely based on empirical observation, but he thought it was an inadequate account of what things truly are. The other pressure in modern biology is evolutionary theory. Since the 19th century, there has been an assumption that species and speciation, the existence of different kinds of organisms, can be explained in terms of population dynamics. Here, the whole is the population, the set of organisms in a species, and the parts are the individual organisms, which again are treated mechanistically as components that interact by random variation and natural selection with each other and with the environment. This is the essence of evolutionary theory, a powerful theory, but it is a theory which colors the analysis of organisms and makes it hard for biology to treat organisms as primary realities. We might call this the Platonic pressure in modern biology. Just as Aristotle found that Plato's idealism made him ignore the material element in nature, modern evolutionary theory tends to ignore the reality of distinctly intelligible unities or forms, treating organisms as incidental unities. Species, on this account, are inherently unstable and subject to change, and differences between species are technically only differences of degree and not of kind. The irony of the theory kicked off by a book about the origin of species is that biology has mostly chipped away at the reality and primacy of species as if they aren't really real. If what we call a species, like sugar maple or weeping willow, is nothing but the provisional result of a history of genetic variation and natural selection, then sugar maples and weeping willows are at best secondary or epiphenomenal, in Aristotelian terms, accidental realities, dependent on something else that is primary, small particles or protein sequences or laws of physics and thermodynamics and supply and demand, or whatever other general forces that determine the survival of the fittest. In fact, with these dual tendencies within biology, the Democritean influence of molecular biology and the Platonic pressure of evolutionary theory, biology has not only avoided coming up with a language for defining an organism, but it is not much closer than it has ever been to defining life. Or rather, it can't do much more than identify features or characteristics of living things. Here, one of the most important such features, and a crucial concept of modern biology, is homeostasis, the active internal processes that maintain the functioning of the living organism. Homeostasis needs cellular respiration, but note that as a chemical process, cellular respiration is driven by homeostasis. The cells can't do their work without life, and the cells are not alive without the life of the organism. Homeostasis, therefore, sounds remarkably like the actuality of Aristotle. And in fact, without much violence to language, homeostasis, from Greek words for alike and maintain, could even be translated as being at work remaining itself, the entelecheia of Aristotle. This next part is called Modern Biology Recognizing Its Own Limits. I have been critical of modern biology, but I have also tried to be charitable and generous. In many ways, modern biology has come to recognize and acknowledge the weaknesses of inherited reductionist assumptions. Biologists are becoming more comfortable suggesting that there are other explanatory factors than the biochemical, even if such suggestions tend to provoke a reaction. In the novel The Overstory, when Patricia Westerford first makes a splash with her research on trees, it is because her fictional paper ends with this sentence: "The biochemical behavior of individual trees may make sense only when we see them as members of a community." That may seem a modest claim, but it suggests an Aristotelian insight into the primacy of organisms. The character of Westerford is partly inspired by the research of the real-life scientist Suzanne Simard, who received her PhD in forestry from Oregon State University. Simard has published research papers for a long time, but her approach is well summarized in the title of her 2021 book, Finding the Mother Tree: Uncovering the Wisdom and Intelligence of the Forest. Using empirical research methods, she has found that the roots of trees interact in a complex underground network, enabling trees to communicate with each other and cooperate in the sharing of nutrients and fighting diseases. If the Darwinian picture has organisms and species as competitive, Simard sees them rather as cooperative. The paper birch and the Douglas fir can share carbon, for instance, if it is scarce for one place but plentiful for another. She finds in forests not only connections between trees, but a hierarchy, with dominant central network nodes, or mother trees. Forests, in other words, are not mere collections of trees, but political communities. Simard is not the only one to explore the active role that trees play in maintaining their individual and communal lives. Peter Wohlleben, a German scholar of forestry, has also published about the social nature of trees. His 2016 book, The Hidden Life of Trees, What They Feel, How They Communicate, Discoveries from a Secret World. You can tell his publisher was really pushing that. describes how trees share information about threats and sources of nutrients, coordinate their activity, protect each other, and work patiently and deliberately in the process of reproduction. And Colin Trudge, a zoologist, had more than 10 years earlier published The Secret Life of Trees, How They Live and Why They Matter. That was 2005. In terms of modern biology, Trudge's book is thoroughly scientific, including a long account of the evolution of plant life in trees. But he still finds it necessary to contrast his approach with a version of Darwinianism that emphasizes competition and randomness, forces of conflict and disorder. Trudge finds forces of order and cooperation, complex systems of harmony, to be just as powerful forces in the story of evolution. And if you think that talking about trees communicating and feeling is a bit of a stretch, consider Paco Calvo's recent book, Planta Sapiens, The New Science of Plant Intelligence, 2023. Calvo argues that plant systems can function essentially like a network of neurons in animals, allowing them to send and receive signals, sense their environment, individually and collectively learning how to make the most out of limited resources and take advantage of patterns in climate and conditions in the soil. And just this morning, I heard on the radio a scientist got an award for research where he showed that there's a certain species of tree that changes the shape of its leaves depending on what the shape of neighboring trees' leaves are. He uses the metaphor of see. It's like the tree can see other trees. He doesn't think it has sense organs like we do, but he thinks somehow the tree doesn't only detect that light is shining on it, but it can detect the patterns that light is shining on it and react to that by changing the way its leaves grow. That's fascinating. Trees have feelings and think. It would be a distraction to debate whether plants have conscious inner lives, subjective feelings, and intellectual cognition. I'm not arguing that. The real upshot of these discoveries about vegetational emotion, wisdom, and communication is that trees and other plants are agents. They are not mere passive subjects of exterior forces, but actively engaged with each other and their environment. Modern biology can no longer deny that living organisms are sources of action. It has rediscovered the primacy of the organism. And the return of the organism is nowhere more important than in the ongoing advances of evolutionary theory. Dennis Walsh, in a 2021 essay on Aristotle and contemporary biology, says that evolutionary biology of our own century suggests that the exclusive reliance on the dynamics of populations, ushered in by the modern synthesis, must be augmented or perhaps even replaced by an account of the ways that organisms participate in and direct the process of evolution. Walsh documents several examples. Increasingly, he says, it is becoming evident that organisms as adaptive, self-building, and self-regulating systems exert a significant degree of control over their own constituent structures and processes. During their development, organisms regulate the activities of their genomes. They select the products of gene expression. They repair and engineer their genomes. They orchestrate and integrate the workings of their subsystems. For each of those, he cites a specific scientific research paper. So in a great and as yet, I think, underreported turn of events, the research program of evolutionary biology, which developed to explain the natures and diversities of organisms in terms of other forces, faces increasingly unavoidable empirical evidence that those other forces themselves are subject to the action of organisms. Evolutionary processes cannot be explained without the primary agency of the organisms themselves. Now, Aristotle, biology, and souls. We have seen that if we simply understand the original meaning of the term soul as the principle of life, it is trivially true that trees and all living organisms have souls. The only interesting question is what sort of thing is a soul, not whether there are such things. We have further seen that if we understand Aristotle's conception of what this principle is, the substantial form or actuality of the living organism, then all the findings of modern biology seem to confirm the need for this notion and to reach for it. This obviously does not mean positing some spooky ghost-like entity, but attending to the empirical findings of biology itself, especially the observable active life of the organism as a primary irreducible reality. In this light, there would only be two reasons to say that trees and other plants and any living thing doesn't have a soul, right? To deny living things have souls, there's only two mistakes you could make to get to that conclusion. Either that would represent a failure to understand the meaning of the term soul in this classical sense as that principle, whatever it turns out to be, by virtue of which something is alive, or such denial would follow from some prior dogmatic philosophical commitment that precludes acknowledging the existence of living things, an inflexible mechanistic reductionism that treats life as only an appearance that is explained away by chemical processes. One of the first philosophers to deny that plants and animals have souls was Descartes, and he was guilty of both errors. When Descartes characterized non-human organisms as machines that lacked a soul, that was neither an empirical discovery nor a testable hypothesis, but a direct corollary of his mechanistic assumptions. Descartes simply rejected the notion of form as an active principle, and he interpreted animals and plants as nothing but complicated machines. For a long time, it was thought that the scientific revolution depended on precisely these moves, rejecting Aristotelian notions of actuality and function, formal and final causes, and accepting only material mechanisms as explanations. Biologist Armand-Marie Leroy calls this the origin myth of modern science. But as Leroy and other biologists have been discovering, Aristotelian ideas of form and purpose turn out to be remarkably persistent in natural science, especially in biology. There is even a field called complexity science that tries to articulate the notion of highly organized, emergent properties, irreducible to their parts. It is, I think, a valiant effort, but to my ear, the phrase emergent properties connotes exactly the opposite of what it is trying to signify. Properties sound to me lifeless and static, not active powers. And if something emerges from, it would therefore seem to be dependent on something else. On both counts, then, emergent property seems a poor way to capture the notion of a whole that is irreducible and active, with ability to direct its parts as a living organism can. The right term for the unified and unifying complex of an organism would imply power and primacy, not a property, but a principle. We can hardly do better than Aristotle's terminology of energeia and entelecheia, or, in a more everyday sense, the psyche, life force, or soul of the organism. And so now to my conclusion, the tree of knowledge. Apart from a few lines of commentary on Aristotle, I have not cited the great patron of this Thomistic Institute, sponsor of this lecture series, St. Thomas Aquinas. But I have been trying to capture the method of St. Thomas's philosophy, always grounded in empirical reality, and carefully engaging the best arguments, the most influential sciences, and bringing all into creative dialogue with Aristotle. I have also been trying to capture the spirit of St. Thomas, whose scientific and philosophical tenacity were inspired by a confidence that God is the source of all truth, the creator of all creatures, the first pure act from which all other actuality flows. G.K. Chesterton described the connection of theological mysticism and common sense empiricism in St. Thomas thus: for him, the point is always that man is not a balloon going up into the sky, nor a mole burrowing merely into the earth, but rather a thing like a tree, whose roots are fed from the earth, while its highest branches seem to rise almost to the stars. I think Annie Dillard captures this Thomistic spirit when she writes, Hasidism has a tradition that one of man's purposes is to assist God in the work of hallowing the things of creation. By a tremendous heave of the spirit, the devout man frees the divine spark trapped in the mute things of time. He uplifts the forms and moments of creation, bearing them aloft into the rare air and hallowing fire in which all clays must shatter and burst. It is this spirit of hallowing nature, it is in this spirit of hallowing nature that I have tried to use my title question, Do Trees Have Souls?, to argue for the relevance of Aristotelian philosophy to the ongoing work of biological science. To use an arboreal metaphor, it might seem that I have been trying to graft a branch of Aristotle onto the tree of modern biology. In fact, what I've been trying to argue is that modern biology, for a few centuries, has been a kind of finicky hothouse plant removed from its natural rootstock, a peculiar scion cultivated under somewhat artificial conditions. Marvelous as it was cut off from a natural source of great vitality, the common sense natural philosophy of Aristotle, which itself was always rooted in biological realism, thoroughly empirical, confirming but illuminating everyday sense experience. So my argument has not so much been that biological science needs a bit of Aristotle, but that for biological science to continue to grow and flourish and reach its fullest potential, it will need to be grafted back onto its source, the original tree of the human sciences. This tree is Aristotle's, not in the sense that the philosopher invented it, but in the sense that he first and most fully discovered it and described it with such insight that after more than 2,000 years, the lifespan of a giant sequoia, it can still be observed and tended and enjoyed by all who seek truth about the nature and causes of creation. Thank you very much.
Thanks for listening to this lecture on the Thomistic Institute podcast. The generosity of people like you makes this podcast possible. If you enjoy these talks, please consider showing your support at www.thomisticinstitute.org/donate. Your donation of even $1 helps us reach more college students and many others with the powerful truths of the faith, and it ensures that we can keep publishing top-notch lectures on this podcast. Thanks a lot.